Every fraction has its own decimal form. Let's do a few problems where we convert fractions to their corresponding decimal forms. The first fraction we're going to look at here, a, is 2/25. Now, every fraction can be thought of as a division problem. 2/25 is equivalent to the division problem 2 divided by 25, written like so. Now, because we want to convert to a decimal here, we're going to do decimal long division. 2 divided by 25 can be written as a long division problem with the 2 inside and the 25 in front of the long division box. The number on top in the fraction always goes in front when we write division in this way, 2 divided by 25. That same number always goes inside the long division box when we write long division. Now, 25 doesn't go into the whole number 2. I can add a decimal point inside, decimal point above, and then I can add a 0 on the end without changing the value. 25 doesn't go into 20. Here, I need to write a 0 up above because 25 goes into 20 0 times. In front of the decimal point above the 2, writing a 0 is optional. You can write a 0 here if you want, but you don't have to. But once we get to the right of the decimal point, if the number in front doesn't go in, we are required to write a 0. We have to. Now, 25 didn't go into 20. I can add another 0 on. 25 goes into 200. Let's see, 25 will go into 200. 25 times, let's think in terms of quarters of money. 4 quarters is $1. 8 quarters is $2. If I think of this 25 as being like 25 cents, 25 times 8 will give me 5 times 8 is 40. 2 times 8 is 16 plus 4 is 20 will give me that 200 exactly. So 8 times 25 is 200. Subtract, I get 0. And here's my decimal for 2/25. That's 0.08. 2/25 is equal to the decimal 0.08. Now let's look at B, 25 over 2. It looks similar to our fraction in A, but in B, if we interpret this fraction as division, we're taking 25 and dividing by 2. If we write that as a long division problem, the 25 goes inside and the 2 goes out in front. That's just like taking 2 into 25. Here we can get started with working with the whole numbers because 2 will go into 2 once. 1 times 2 is 2. Subtract, 2 minus 2 is 0. Bring down the 5. 2 goes into 5 2 times. 2 times 2 is 4. 5 minus 4 is 1. And now, if I wish to continue to obtain a decimal answer here, I have to indicate my decimal point to the right of the 5. It goes right above to the right of the 2 in the answer. Then I can add a 0 on the end. 25.0 is the same as 25. This 0 I can bring down. 2 goes into 10 5 times. 5 times 2 is 10. Subtract, I get 0. So my decimal for 25 halves is 12.5. Let me write that here. 25 halves equals 12.5. I just want to compare these two results that we have. 2/25 is a fraction that's less than 1 whole. Notice that the decimal that we got for that has a 0 whole number part. There's no digits to the left of the decimal point. 25 halves, however, is a fraction that's more than one whole. It has a larger number on top. And sure enough, its decimal, 12.5, has a whole number part of 12. Now let's look at C, where we wish to convert 3/8 to a decimal. Thinking of that as division, that's 3 divided by 8. When we write that as a long division problem, 3 goes inside the long division box. 8 goes out in front. 8 doesn't go into 3. So right away, I can put down my decimal point inside and my decimal up above. If you want, you can write a 0 above the 3, but the 0 is not required to the left of the decimal point. Now I add a 0 behind the decimal. 8 goes into 30. That's going to be, let's see, 2 times 8 is 16. 3 times 8 is 24. 4 times 8 is 32. That's too much. So this is 3 times 8 is 24. Subtract. I get 6. I can add a 0, bring it down. 8 goes into 60. 8 times 8 is 64. That's too big. 7 times 8 is 56. 7 times 8 is 56. When I subtract, 60 minus 56 is 4. I can add a 0, bring it down, and now 8 goes into 40 5 times. 5 times 8 is 40. And finally here, when I subtract, I get 0, which means the process is over, and I have my decimal 0.375 for 3/8. The fraction 3/8 is equal to the decimal 0.375. If you like, you can write a 0 in front of that decimal point. You could write 0.375. That's another way to write this answer. Now let's do just one more. Let's compare what we just got to 8/3. The fraction 8/3 in D can be written as the division problem 8 divided by 3. If we set up our long division box now to get a decimal answer, we put the 8 inside and the 3 out in front for this one. 8 on top here, 8 in front here, 8 goes inside in the long division. 3 goes into 8. 3 goes into 8 2 times. 2 times 3 is 6. 8 minus 6 is 2. And now if I want to continue, I can write down my decimal point, write it right above in the answer, and then I can put a 0 behind the decimal point inside the long division box. Now bring down the 0, and I want to know how many times does 3 go into 20? Well, 6 times 3 is 18. 6 times 3 is 18. 20 minus 18 is 2. I can add another 0 and bring it down. Once again, I'm asking myself, how many times does 3 go into 20? 3 goes into 20 6 times. 6 times 3 is 18. And when I subtract, I get 2. It looks like the process is starting to repeat itself, and I think it is. If I add another 0, bring it down, I have a 20 again. 3 will go into 20 6 times. 6 times 3 is 18. When I subtract, I'm back to a 2. Of course, I'm going to keep getting here 6's over and over again. I have 2.666 repeating. Now there's 2 ways we can write our answer for this. We can say 8/3 is equal to 2.666, write a few 6's, and then dot, dot, dot. The dot, dot, dot on the end represents the fact that that pattern continues on and on forever. Or you can also write 2.6 with a line, or a bar we say, above the 6. That bar represents the fact that the 6 gets repeated forever. So 8/3 is 2.6 0.666 repeating on and on. Just compare 3/8, which is 0.375, a decimal that is less than 1 whole, to 8/3, which is equal to 2.666 repeating. That's a number that is more than 1 whole.